All right. Our next is a tag team presentation, beginning with Igor Svilagoy, who's from UCSD, and then he will hand off to Jamie Frey, who's one of the Condor developers.
Okay. Can people hear me? Yep. Okay. Let's see if this works. How do I go? Yep. Okay, so I'm here to talk to you about glideins and Kubernetes, and I'll extend it a little bit more since I got some ideas yesterday. So we'll see how it goes. So first, what are glideins and why do we care? Well, a glidein, which is called also a pilot in other areas, it's basically just a dynamically provisioned compute resource that joins a Condor pool. Nothing more than that. And these days, most resources in the OS pools are glideins. So I would claim that modern DHTC would not exist without glideins. So we should care. So glideins are there to create an illusion that we have a common resource pool when really there are many independent resource providers that are giving those resources to us, and they are completely independent, managed by different people. They don't even know. Well, probably they know what OS pool is, but they never look at it. And one of the really powerful features of the current glidein infrastructure is that it's really provisioned just in time. So the glideins get created when there is a need for them. So you will get a glidein sent somewhere only if there are jobs in the Condor queue that have nowhere to run. At least to the first approximation, then we can discuss if it actually happens this way, but that's the idea. Now, for the purpose of this talk, I will not talk how we decide where to send or when to send them, but I want to stress that glideins are not user task specific, and I will mix task and job here just to make some people who like naming mad, but not exactly, but that's fine.
User task specific.
Job specific, if you want. Each glidein, when we send a glidein, it's not tied to a specific user and it's not tied to a specific job. You send a glidein, it starts up, and it can pick any user and any.
Why? So convince me, why is that important a distinction?
You will see.
Why do you care what motivated me to start a glidein? Because when we are doing annexes, then we have a strong affinity.
Yes, but you don't.
But you say you don't care about these cases.
Exactly. That's how it works in outside of annexes. Yes.
Okay, let's see.
And this is important for the purpose of this this talk.
Okay.
Because when you have a single glidein, then can serve many different user tasks, like I call them, which are different jobs, possibly belonging to different users. Each one may have a completely different software needs.
So you are saying, what happens if you have a glidein that has to be multi-tenant?
Yes, which is all.
Yeah, so that now and actually, how do you protect different jobs in a glidein? And once again, it doesn't matter what motivated me to do it.
As I said, I'm not talking about what motivating me. What I'm saying is, once the glidein starts, that's the reality on the ground. A glidein doesn't know when it's submitted.
And I have a problem because I have no idea what do you mean by user. How do you define a user?
I don't.
So why do you use the word user in your slide?
Because it's a different. I could call it entity. I could call it an identifier if you want, because there are so many names. There are just different entities that are different by definition, and they simply don't trust each other.
So the thing is that you're running in a glidein jobs that don't trust each other.
Essentially.
Okay.
Yeah. So this brings a lot of interesting questions, but in the end, how we solve them pretty much everywhere is through containerization. So most jobs or tasks come with their container image, and the pilot launches that container image so that everything is nicely packaged as a nice side effect. That also protects the pilot from the user, because while the pilot can see inside the container, you cannot see from the container out into the outside. So that is all nice, and we like it, and we rely on it, pretty much rely on it these days. We really don't want to do it without. And we do it because anytime we go to bare metal systems, we usually have Singularity or Obtainer that allows us to do it. So yay, everything works just as it should. But there is this thing called Kubernetes that is starting to become popular. Nothing else, there is a big project called NRP that I happened to work with that's Kubernetes-based. So we have to care about it. So what's the problem with running glideins in Kubernetes? Well, there's a little detail about Kubernetes is that it's not bare metal. And if everything in Kubernetes must be inside a container, no exceptions, which means the pilot itself starts inside a container. So if a pilot wants to launch a container inside a container, we get to the whole idea of nested containerization, and that's typically not allowed. It's allowed somewhere, but not in others. It's allowed only if you are privileged, and even then, sometimes you can, sometimes you can't. So I would say that's not something we really want to keep supporting in the long term. Is there a better way? Can we do better? So, being this talk about Kubernetes, Kubernetes actually has a really nice property that we usually don't consider when we go to batch systems. When you submit a job to a batch system, it's one thing. It's a job, an entry point that then does other thing. In Kubernetes, that's not the case. Its task, which is called the pod, really it's supposed to be a set of containers, set of independent stuff that just happen to be co-packaged and have certain privileges between them. You can submit one, but it can be many. So the idea here is, since we can have a set of containers, why don't we use one container for the pilot and one for the payload, which would be the job, the task. You can call it any number of ways. I call it payload most of the time. And looking around, well, nobody has done it before. So, but at least in principle, it looks like the right thing to do. So I spent some time thinking about it, and I think it can be done. And this talk is about this. And unlike, I think, pretty much everybody else in this audience, I don't have an implementation. I'm trying to sell you an idea and an implementation. So I'll turn it on to Jamie, who will start discussing what do we need to do to make this a reality, starting from what the heck a glidein is actually doing.
So thank you. So we're going to review what the life cycle of a glidein looks like, and then we will see how we can fit this sort of workflow in the sort of Kubernetes environment.
I need help here. Okay, at least in my world, there is a glidein, and a glidein is launching an execution point.
Yes.
I didn't hear in Igor nothing about an execution point, because in my book, the glidein doesn't join the Condor pool. The execution point joins what is here the pod? The pod is the glidein, or the pod is the execution point, or the pod is the payload? I need help here, because for me, it's the nesting here is glidein, execution point, payload. So we move ahead, but I'm still lost.
Okay. So we try to structure this since we think this setup is sort of applicable to frameworks that are beyond the sort of the HTCondor world. We kept the terms fairly non-Condor specific. But so the glidein is the initial thing that lands on the node. And then what we're calling the pilot is the execution point. So here in this illustration, the glidein is initially this green box at the upper left, which lands on the environment where it's going to run this machine with some resources available. It looks around, checks out the environment, makes sure that everything that the environment it's running in is suitable for the tasks that it is that we are intending to run there. It will then configure the pilot or the execution point to be able to run there, and then starts it up. And the rest of this workflow is the execution point. So it starts up, it joins the larger Condor system, and looks.
What happens if the payload is an image of a container? Is that part of the model, or it cannot be? Because Igor tells me that nested invocation of containers is a no-no. So I am completely confused here because we are talking quite a bit about a container, invoking a container, and we are, so.
This is completely abstract. So this has nothing to do with Kubernetes, has nothing to do with Condor. This is just how, from a logical point of view, a glidein works. And because we need to understand how things work at the conceptual level before we can we go into the actual implementation. So we are trying to here just to discuss what any glidein essentially does to a first approximation without going into any details. And then after we understand what the heck is going on, we'll map these steps into the actual implementation.
It's fine. Move ahead. All I can tell you is that at least one person in the audience is not following you. So
we'll see
good luck.
We're trying not to front load.
Anyway, so a typical glidein running in the sort of the environments that we exist in today. Your execution point starts up, joins the larger Condor pool that it is a member of, and try ways to get matched with tasks. Are there any payload jobs available for it to run? If it finds one and is handed one, then it will fetch all the details related to that job. Any input files, the container image that the job is intended to run within, and all those details. And then it will launch the task inside its provided container. The glidein will then monitor the task to make sure, monitor its usage, how much memory disk it's using, is it behaving properly, reports that back to the scheduler that the task came from, and we'll wait for the task to exit. In certain situations, it may be required to terminate the task prematurely, either because the task is misbehaving, it's gone over memory, or the scheduler has decided that the task is not suitable, the user removed it, or the whole pilot itself is being evicted from the system. So, and then whether the task exits of its own accord or the pilot had to terminate it early, the pilot then gathers up all the output, which can include the final resource usage, any output files, the exit status of the task, and reports those back to the source scheduling system. The pilot then cleans up all the resource usage of the task, files, processes, anything that may have been left behind, and then optionally goes into loop, sees if there's any additional tasks that it should run. Now, in many situations, with sufficient resources on the node, this loop may be running in parallel for running multiple tasks side by side. And then eventually, either based on lack of new tasks available or some time limit, the pilot may then decide it's time to shut down. It does some final cleanup of its own normal setup and installation, and it would exit. So this is the sort of the normal life cycle of a glidein, and its pilot or execution point that it is encapsulated inside it.
So now that hopefully we have an idea what the glidein does, let's try to map it on how we would make it to work in a Kubernetes environment. We know this works in a bare metal batch system because we have been doing it for the past, I don't know, 20 years or thereabout. But when you want to do it in a Kubernetes system where you don't have nested containerization, how can we make it to work? Now, there are several mechanisms in Kubernetes that I need to exploit in order to get there. So the first thing, we need a way to share data between the two containers, right? I got certain amount of data that belongs to the job. I need to inject it in the container. Well, it's pretty easy to do in Kubernetes. In a single pod, you can have a shared area between two containers. 101 of Kubernetes, nothing too fancy. And another useful thing is I can have more than one areas, and one I will keep private. So I can keep my pilot stuff that I don't want the payload to see private, and it cannot use it. So nice protection. So this is easy. Now, as I said, I don't know in advance what job will I run, what payload will I run when I submit a pilot. But a pod, when it's created, needs to know all the container images that will be part of that pod. How do we solve this? Well, it's actually relatively easy, especially if you run a modern version of Kubernetes. It didn't used to be easy, and finally it is, which is great. So essentially, you start a pod with a pilot container, which I know what it is because I own it, and then a random dummy container that contains nothing with a wait script doing nothing, just wasting resources. Then, the moment I know what the payload container is supposed to be, I ask Kubernetes to replace the container image of the second container and restart that container. Since, I don't know, 6 months or maybe a year, it's a standard feature in Kubernetes that can be done. It's not a privileged operation, so there is no reason not to do it. So all you need is a service credential that you ask Kubernetes at pod creation. Make sure only the pilot container can do it and not the payload. You don't want the user to actually change the container image of the pilot. But apart from that, it's very straightforward. The mechanism there, you can do it. I have here an image of how things work. So you start, so this is really the timeline from top to bottom. You start with a generic container on one side and a pilot container on this side. And you start your initialization, you fetch all the information you need. Once you have the container image, you tell Kubernetes to change it. And then, or in parallel, you put all the stuff on the shared file system, and the payload can start. Now, we need some glue in between those two, and it's that startup script that I will describe a little more in detail in a future slides. But since the pilot really can access the shared file system, it can create it, it can configure it. So it's easy. Well, it's doable. I'm saying it's easy, but all the mechanisms are in place. Now, as Jamie said, the pilot wants to monitor what's going on in the payload container. And by default, you can't, because one of the principles of containers is we isolate you from the rest. So since we are in two different containers, normally you cannot look to each other. There are many ways you can go around it, but in Kubernetes in particular, it's easy to say, well, I don't want this level of protection. Make sure that all containers in a single pod can see the processes of each other. And it's not a privileged operation. You can just say during the definition, I own all the containers, so I'm happy to do that. And so you do this, and each container can see processes of the other and send signals between the two. In order to protect, but we still want protection of the pilot from the payload. So in order to obtain that, we drop privileges in the container, in the payload container. So there is a concept of pseudo root in the container. So the pilot starts as a pseudo root, but you don't allow the payload to have pseudo roots. This is pretty much the same as you usually do in a bare metal installation of Condor. So it fits perfectly in the Condor philosophy. It's not how glideins usually work, but it's actually how bare metal installation of Condor actually works. So I'm not worried that it has problems. Maybe Todd has, but hopefully not, because we do have some bare metal installations of Condor. A few more words about the glue script. As I said, it's important. So what does that glue script do? And it really runs in the payload container. The pilot is just that they're doing other stuff, but the script is really all running on that side. And by default, it just starts up and does nothing. And while it does nothing, it's because it doesn't know what to do. The information has to come from the pilot side. And how do we get there? Well, we put something on the shared file system. So this glue script does nothing until the appropriate information shows up on the shared area. And then once it's there we go. Which means that in the beginning, when you have a dummy container, I do never anything because the information never appeared on the shared file system. And the pilot will really write in the shared area only after the proper container has started. But assuming the data is there, now the script can do all the initialization that is needed for the task payload, whatever you want to call it. And at that point, once it has done all the preparation, it can launch the task processes, but dropping the privileges in the process. So while the glue script runs with high privileges, nothing that is user provided will ever run with high privileges. And it's relatively easy to implement, so it's doable. That pilot process is there, that glue script also there waits for those processes to finish. And since it is a parent-child relationship, it can retrieve the exit status, and it can write it back into the shared area. So it's propagated back to the pilot, so the pilot actually gets all the information. So using these tools, I think we have all the mechanisms we need in order to implement this. Of course, there are changes that need to happen in Condor because Condor doesn't work this way right now, but we believe all the mechanisms you need are in there. It's just a matter of implementation. And I would like to thank a student of mine, Grace Union Zhu, who made a prototype with just a bunch of bash scripts to validate that all those mechanisms actually work the way we think they are. I have a couple, that was all I was supposed to talk initially. If I'm allowed to go 2 minutes over time, I have a little bit of bonus material that reflects on things that I heard yesterday and I think could be important. One is, can we use this principle outside Kubernetes? For example, if we have a bare metal Docker installation, could this principle still apply? Again, without giving any additional privileges to the glideins, because we said, admins are not really happy with it, and I agree. I would claim many of the concepts I described so far are not really Kubernetes specific. However, you do need a little bit at the bare metal level to mimic some of the things that Kubernetes does. If not, at least somebody needs to change the container image. You cannot do it from inside. So maybe a little bit of layer there, it's needed, but it may be acceptable for the admins to actually install a teeny layer on their systems, bare metal, to achieve this. And the limited container isolation, which means exposing the pin namespaces between container may not be achievable, but that's not a strictly necessary feature of the system. It just makes things easier, and there are other ways to work around it. So if we want to support that, maybe we should consider these alternative approaches. The other part is, how about pilots in pilots? Because I'm not solving the problem of nested containers. I just work around it. And we saw a lot of pilot talks yesterday. Yeah, it's turtles all the way down, which is unfortunate. The good news is the vast majority of HTCondor jobs is not pilots in pilots, so my approach will work for them. So if we are happy to support 80% of all the jobs, things will work. But 20% or whatever it is, it's not negligible. So is there something we can do about it? Well, one possible solution, I don't have time, that's the problem.
Sorry to say, in your typical way, you are fluff, fluff, fluff.
Yes, I don't have time.
Where did you get this statement that most HTCondor jobs are not pilots? Where did you dream this thing up?
That's my impression. I'm not.
So you are wrong, and you are making. I mean, all of the WLCG tier ones are running Condor that's only running pilots.
They are not.
No?
No.
What are they running?
The glidein is the pilot, but they don't run another glidein inside the glidein.
But they are Condor themselves.
This is,
You are saying here that most HTCondor jobs, I mean, it's amazing how you can, in your traditional way, brush things up and down. This is, if you're saying that most pilots don't run pilots,
yes.
But this, look at what you wrote. Okay, that's, and I have a lot of questions about all the other stuff that you said, but this is just brushing, because we can do something, a lot of arrows and lines and boxes and stuff, but this is wrong. This is fake news.
I disagree, but okay.
Okay, keep.
We agree to disagree. That's fine. So one possible solution is that the pilot inside the pilot doesn't need to be inside the container, right? It's a relatively stable piece of software maintained by experts, so it's feasible that those could not be containers. So in that case, all we need to do is just allow that pilot to use the second container somehow. They said, I dreamt this yesterday, so I don't have an answer. Just a potential idea there.
Because you are ignoring situation where we are running a Condor like we are doing here. We are running a Condor system in Kubernetes. And then we start all the, what you call pilot or gliding or whatever you are calling it. So the starting point is already nested.
Yes.
So according to what you are selling here is that they should not be nested. They should be running these things next to each other and communicate via the file system.
No, not via file system. This one, all I'm saying is that the pilot itself doesn't need to be a container. So if the pilot is started by an HTCondor execution point, yes, it can be run in a container, but it doesn't.
In a Kubernetes container.
Doesn't matter if it is Kubernetes or not.
But you told me that Kubernetes doesn't support nested containers. So
just two. I know. So let me just flash this and we're done. So the other possible solution is make three containers instead of two. And essentially another one that assumes, well, we will run containers, pilots inside pilots, and that's the dedicated one. I'll stop here, but that are just short things I thought overnight because I thought about it yesterday.
All right. Thank you, Igor. Since